This video is the second in a series covering the facets of dimensional analysis, otherwise known as unit conversions. If you haven't watched the first in the series, you'll want to go back and watch that first before watching this one. And now my forward thing is not working. This video is the second in a series covering the many different ways that we approach problems involving unit conversions or dimensional analysis in chemistry. If you haven't watched the first video in the series, Dimensional Analysis number 1, make sure you check that out first before watching this one, since this builds on that video and assumes you've already watched it before you get here. When we're looking at a multi-step unit conversion, we want to think about where we need to go in the process and where we don't need to go in the process. Because when you're faced with a unit conversion problem, often you're given a variety of information, different units and their conversions that may or may not actually be helpful. So when we're reading this question down here, how many moons are contained in 4,050 hearts, our objective here is to figure out a pathway that'll take us from hearts to moons. So when we look at our choices up here, I'm going to look and see what do I have for hearts. Well, I've got hearts right here, and I've got hearts right here. Now, the hearts that go to the stars, I'm just going to trace through here and see if that's helpful. Let's see. I can go from hearts to stars, and then down to stars, and that will take me to clouds. And then, oh look, I've got clouds that will take me to moon, which is where I want to go. Now let's say you didn't know that that's what you wanted to do. I'm going to erase all of this. And let's say you looked at the other conversion, which was I have 4.60 hearts. So that would take me to arms. And arms, let's see, my only other conversion for arms would be to go here to trees. Now trees, oh wait, this would work too. And then trees take me up here to clouds, and clouds, like we said, take me to moons. So this actually illustrates the fact that there's lots of different ways to do a problem, and they're all equally correct. We're all going to get to the same place. It also highlights the importance of showing your work when you are completing an assessment that is going to be graded by your instructor. Because basically here you want to communicate that you know all the pieces to completing the problem. And also, if you mess up one of those pieces, sometimes partial credit can be given for the pieces that you did know how to do. So we have two different ways to do the problem. Since I just mapped out this second one, let's go ahead and do it that way. So I have, except in my example I did it the other way, so we'll erase. Get rid of this. And go back, and we wanted to go from hearts to stars. So we're going to start here. And I see that I've got 2 stars equal to 1 heart. So I'm starting with the measurement that I've been given, 4,050 hearts. And I know that since I've got hearts here, I should have hearts down here as well, because I want to cancel out that unit. And I see that there's 1 heart per 2 stars. And at that point, hearts cancels out, which is great. I'm in stars. We said that 1 star was equal to 20.03 clouds. So again, stars are up here, so they should also be down here. So I have 1 star, 20.03 clouds. Stars cancels out. And then finally, I noticed that I had moons related to clouds here. 1 cloud. Again, canceling this unit up here with this unit down here. They have to match in order to cancel out. Oh my goodness. And we're back. momentary power issue with my screen. So I've got one cloud and 0.0, whoops, and now my screen's not working. No, there we go. 0.0047 moons, or moon in this case. And then now it's all over except for just putting it into my calculator. So 4,050 times 2 times 20.03 times 0.0047, and that gives me 762.5 and a lot of other numbers. But I noticed that in this number I only had 3 significant figures, here and here and here. That last 0 didn't count as a sig fig because I don't have a decimal point in the number. So I have 1, 2, 3 sig figs. This number is going to be dropped, but it's 5 or greater, so that means my next number has to be rounded up. So my answer becomes 763. I want to make sure that I write my units attached to the number and then box my answer so it's really clear to whoever's grading it that that's really what I want as my answer. Okay, so now the typical loss of water via sweating for a human is 450 milliliters per day. What is the volume in gallons lost in 1 week? This problem has 2 types of units. I've got 450 milliliters per day, and per, remember, tells me I'm dividing. So really this is 450 milliliters per 1 day. That's what I'm starting with. And then it asks me to figure out the gallons lost in 1 week. So really this is gallons per 1 week. So the problem is asking me to take this value and turn it into those units. This is a compound unit conversion. So I have 450 milliliters per day, and I need to get to gallons, and I need to get to weeks. And the great news is I can take each of those separately. So I can tackle the milliliters to gallons, which is my volume conversion, and my days to weeks as my time conversion, and I can just think about them as 2 separate processes. So I know that there's 1,000 milliliters in 1 liter. And if you watched earlier unit conversion problems, you know I listed out some common unit conversions that we use, and that's what I'm referencing now. So it's good to have that in front of you if you don't already. And I know that 1 liter from that list is equal to 0.265 gallons. At that point, liters is canceled and liters is canceled, and there's gallons, which is the unit that I wanted. Then I want to deal with days, which is still over here. And I really want to go from days to weeks. Now since days is down here in the bottom of the fraction, up here is where I need to put days so that they cancel one another out. And we know there are 7 days in 1 week. So that takes care of my days, and now I'm in gallons per week, which is the unit that I wanted. So 450 divided by 1,000 times 0.265 times 7, I get 0.83475. I want to check my significant figures. Up here, I see there's 1, 2 significant figures. That last 0 doesn't count as a significant figure because there's no decimal point. So I need 1, 2 sig figs. The next number is less than 4, excuse me, is less than 5. So I don't need to round up, and this becomes 0.83 gallons per week. Oops, I went backwards. Go forwards. One more example. This time we have a patient who needs medication at a rate of 0.050 nanograms per minute. So again, that's telling me I'm dividing by 1 minute, and the IV machine is programmed in ounces per hour. So that's OZ over hour. Here's my mass unit, and here's my time unit. And so I need to take nanograms to ounces and minutes to hours. Okay, so using what I know from the metric system, 10 to the 9th nanograms equals 1 gram, and using from our commonly encountered unit conversions, 28.3 grams is equal to 1 ounce. And finally, so that takes care of my nanograms and my grams. They've all canceled. There's my ounces. That's good. I still need to deal with the minutes down here in the bottom of the fraction. And we know there are 60 minutes in 1 hour. Notice minutes is up here to cancel the minutes down there. That leaves me with ounces over hours, which is the unit that I want. Put it into your calculator. It's a good one to practice doing with me because sometimes putting 10 to the 9th into your calculator can go incorrectly. So you want to just double check here and make sure you come up with the same answer that I do. And times 60. And I get this number, 1.0600 times 10 to the negative 10th. If you ended up with a positive exponent here, it means that you need to put parentheses around this number when you divide it in your calculator. If you ended up with 10 to the negative 9th, it means that you're putting in your exponent incorrectly. And you can drop me an email and say, hey, I did this, I'm not sure what to do. It often has to do with if you're using an EE button on your calculator when you enter that. But back to this problem. I only have 2 sig figs, this 5 here and this 0 because there was a decimal point. So I need 1.1 times 10 to the negative 10th, and it is in ounces per hour. Box my answer. So